Yeah. All right. Today's topic is heading and bearing. Okay. Actually, we're gonna kind of regress back on the book. This is actually part of chapter 4, and we're already past chapter 4. Yes, there is a book for this class. Okay. Uh, this was part of chapter 4, section 8, which we already covered, but I decided to skip this part. Okay. This is gonna get us ready for vectors. We're gonna start learning about vectors pretty soon. Okay. All right. Heading and bearing. What that means? It means direction. Okay. Like where are you heading? Okay. Pilots, people with ships, who else? Surveying crews, they need to know coordinates, okay? You've ever heard of a compass? Okay, want to make sure. What is a compass? Not for geometry, but a compass that looks... Correct. North, south, west, east. Okay? Yes. I don't have time for that right now. Hold on. All right. So, want to make sure we're all familiar with this. Okay? We've all seen it at one point at least. Okay? All right. If you use one of these things, it typically has a needle, right? And it moves as you're walking, and it tells you what direction you're going. Okay? So, if the needle is between the north and the east, you're going northeast. If it's between north and west, northwest. Okay? We're good with reading these things. Okay? All right. So, sometimes, okay, you are going to be given an angle without an actual direction, like without me saying north or south or west or east, okay? If you are just given an angle, that means that a compass has how many degrees all around? 360. Now, unlike the unit circle we would begin from here and we would go counterclockwise, right? With this compass, and when we're talking about direction, you still have 360 degrees all around, but you start from the north, always, okay? You start from the north, so this is 0 degrees, and you go clockwise, okay? So you go all the way to 360 degrees. Okay?
Oh, that's how you do the degrees.
Okay? Alright. So let's say I give you the following problem. There is a plane that flies on a heading of 120 degrees at a speed of 200 miles per hour for 2 hours. Okay? So we have a plane that's flying on a heading of 120 degrees at a speed of 200 miles per hour for a total of 2 hours. Okay? I want you to draw a diagram where you are actually plotting this information. Okay? So, here's what I would do. Draw yourself a plane with the north, south, west, east, and plot the angle. Where would your 120 degrees be located? Direction. Okay? So that means, okay, and label it. If I don't give you, sometimes I'm going to give you a grid that is actually labeled. For example, it would look something like this. Okay? And it's nicer, but honestly, I don't have the time to do that all the time. So, if I don't give you something that looks like this, you got to make sure you label when you graph it. Okay? The other thing that you need to include is that since it was traveling at 200 miles per hour for 2 hours, you need to tell me the distance that it traveled, which in this case would be 400 miles. If I can read this without looking at the problem, I can read that this, whatever it is, whether it's a ship, whether it's a plane, whatever it is, it's traveling at 120 degrees for 400 miles. Okay, without needing all this information up here. Okay? We're going to get there. Okay? Alright. Sometimes you're going to see this. Sometimes you're not. Some people actually include like another ray, like this, and like that. I'm not going to count points off, but I understand that if you only draw this ray, I totally understand it. Like, I understand that it's 120 degrees. The reason why I brought this up is because I want you to understand that this doesn't mean that the plane started here, it traveled here, and then it traveled here. The plane started right here. This is where the plane took off. So whatever airport it took off. This is where it started, and it went on this direction, 120 degrees from the north. Cool? Yes. I'm just letting you know, you might see it like on the homework or maybe on the test, because it's a CBA and I didn't do the CBA. Okay? Alright. Cool? Alright, so I want you, now on your own, try the following. You have a ship. Not necessarily. It's your notes. That is traveling at a bearing of 285 degrees. What's that? We'll talk about it in just a second. Okay. At 50 miles per hour for 5 hours. So go ahead and make yourself a diagram of this. Okay? Graph it. Sure, Victor. If that makes you...
Is bearing the same thing as heading?
We're going to talk about it in just a second. Okay? Right now, this is... Okay? This, I know I'm using the word bearing, but I like to refer this to more as a head. It's heading in this direction. I'm going to tell you what a bearing is in just a second. Okay? But they're almost the exact same thing. Based on the previous example, I should be, if I'm going 285 degrees, where would I be at?
A little bit above west, so you'd be in northwest.
Northwest, a little bit above of it, right? Because this is 270, so I'm going to say about there. So, what's that? Yeah, be careful. We're not talking about quadrants here, okay? So like I'm even holding myself back from saying quadrants because we're not talking about an actual plane, right? We have a compass, okay? And what's the distance that we travel in 5 hours? 250 miles. Okay? Good? Yep. If I just ask you to draw a diagram, as simple as that.
Wait, what's the difference in bearings?
Okay? You guys ready? Okay. Here's what a bearing is. Here's what a bearing is. It measures the acute angle, a path, or line of sight makes with a fixed north-south line. A bearing is a measure of the acute angle a path or line of sight makes with a fixed north or south line. In English, you ready? What this means is that I'm actually going to give you direction with this. I'm going to say north, 45 degrees northwest, or 45 degrees southwest. Okay? That means that you are no longer going to have angles that are what? Larger than 90 degrees. Okay? So, if I give you an angle that is larger than 90 degrees, okay, that's a heading. Okay, you're heading on that angle. If I give you an angle that is less than 90 degrees with direction, so if I actually tell you north, south, west, east, then that's a bearing. Okay? Yes?
So for that specific question for the shift,
Mm-hmm.
would you have to find the distance between like 85 and the North Pole?
I'm going to show you how to do it. Okay? So this is how bearings look. Are you guys ready? Okay? You're going to have your compass. You're still going to have your north, south, west, and east. Okay? So here's your north, here's your south, here's your west, and here's your east. Okay? Here's how you measure them. With the north, 0 will always be starting here. Okay? Whether it's northwest or northeast. And it goes on that direction. Okay? So that means you can go from 0 to 90, right? Or from 0 to 90 degrees. With the south, guess what? It starts at the south pole and it goes this way. Okay?
0, not 180?
Correct. So let me ask you, on this previous question up here, are we on the north or are we in the south? So since we're starting from 0 here, what's the difference between here and here? 75 degrees northwest. This is how they write it. They put the N first for north, then the degrees, then the west or the east, whatever it is. Okay? Okay, because it's 90 degrees, right? Between, if you remember, this is 270. Between 270 and that's 15. So 90 minus 15 is 75 degrees. Okay? Yes? They will give you the entire thing. They'll give you the direction of it. If it's just an acute angle without the direction, then you're going to use it as this. Okay, you're going to start with 0 up here and just graph it. If it actually gives you direction, so if it tells you south, north, whatever, then you're going to apply this bottom part. Okay, you're going to start, if it's north, you start 0 here and go either west or east, and then south, west or east. Cool?
So like for the first problem we did, it would be what's it called, south and 70 west. I mean, sorry, south 60 east.
Right. Hmm. Okay. On the new, yeah, we're gonna do. If I give you 285, then that means it's 285, and I don't give you any direction. Okay. The only way I can give you direction, like actual coordinates, it has to be an acute angle. Either way, if I use heading or bearing, I don't like that some people use the word bearing because you really shouldn't use the word bearing. But even the book is using it, and it kind of like upsets me a little bit because a bearing is an acute angle. So what you have to look for is just make sure that there is no direction in it. Okay, you're gonna have to make that judgment. I can see their argument of why they use heading and bearing using the same thing because it literally means the direction. Both of them do. But if you want to be like really picky, a bearing is an acute angle with direction included with it. Okay? Yes, ma'am.
So if you had a graphic like that, the
Mhm.
would you have to, how would you do it?
You still do the same thing. Make sure you include your north, west, south, and east. Make sure they are labeled in there.
Would you still say 285?
But instead of saying 285, you're gonna give me the acute angle forms. Okay? Cool? Alright, so let's practice some of this. So I'm gonna give you a couple of problems and I want you to try them on your own. John drove That's just how we write it. So grab that. He drove that bearing right there for 100 miles. Make a diagram. And I'll go ahead and give you the other one as well. Sarah swam for 20 miles.
Whoa.
Unrealistic, but maybe. Well, actually, maybe someone can do it. I don't know.
That's a lot. Actually, yeah, they can. Something on miles is hard.
All right, check your answers. Make sure you got them correct. Any questions before we move on? We're good? Okay. All right. Guess what? Sometimes I'm going to give you two headings together. So, for example, you could be traveling in one direction, and then you turn, right? And then you can turn again, right? Everything, like, think about a plane. Do they ever really just travel like a straight path? Not necessarily, okay? So, this is where the application comes. Are you guys ready? Okay? All right, I need you to write down the problem that I'm going to give you, okay? Please write down the problem, pause the video, and press play when you're ready to go. Okay. Since we have two bearings, we're going to have to plot one at a time, okay? So here's what I want you to do. We're going to start with the first, which we're going to pretend that this is the port, okay? And if we have a compass, this is north, this is south, this is west, and this is east. You guys agree? Okay. According to the problem, it says that when you took off from the port, where did you go? You went west, right? Directly west. So we're going to take off to the west. And how long did it go for? So 40 knots. Right? It was 20 knots per hour. And since we took off at noon, at 2 o'clock, that will be a total of 2 hours. So 20 times 2 is 40. So you guys okay with me saying 40 knots? Right? All right. And then it got that far. After, at 2 p.m., the ship changed directions, right? It changes direction to 54 degrees northwest. Okay, so here's what I want you to do. At this point, you're going to draw another north, south, west, east. And obviously, you know that that's east. You guys okay? The more you do this, the less you have to draw the actual north-south plane, if you ask me, okay? But I'm just going to show you right now, okay? So if it's going 54 degrees, okay, northwest, I'm going on this direction, right? But where do I start? From the north, right? So from 0, I need to count 54 degrees this way. You guys okay with that? So that means that I'm just going to draw this going in this direction. Okay? But I'm going to label this. This angle right here is 54 degrees. Cool? Because I started from the north and we go 54 degrees from the north towards the west. Okay? And then it says that it traveled for an hour, right? So this would mean that this distance right here is 20 knots. Okay? It wants to know at 3 p.m., which is at this point right here, how far are we from here to where we started, all the way down here. This is where we took off. It wants to know this distance, and it wants to know the bearing. Okay? That's the two things that was asked. Find the bearing, starting from here, and find the distance. So we're looking for this distance right here, and we are looking for what angle? Is it this angle or this angle? It's the one on the outside. Okay? What would it be easier to find? The bearing or the distance?
Bearing.
Okay?
Yeah,
They're both easy to find?
Yeah, if you know how to do it.
Okay. That was awesome. All right.
No way.
All right. I'm going to open the floor. Any thoughts of how we can go about solving this?
Well, we can just use the variety.
All right. Guys, go ahead. Kevin, what you got?
Can I go?
Sure.
Find this part, because this section would be 36 degrees, and we use sine to find the length of this side, x, and then we find this side as well. Then we use the Pythagorean theorem to find the height.
Fantastic. Can you erase that for me real quick? Very, very good. Awesome. Okay? Yes. Absolutely. Okay? At this moment, okay, we have what kind of triangle right now? We don't really know, right? So far in this class, trigonometry, we've done right triangle trigonometry. Do you guys agree? We have not done anything with any other kind of triangle. So, he said, what if we try to make this into a right triangle? By doing this. Because we know that this is 54 degrees, and from here to the west, that's 90 degrees, we can find out that this angle right here is how much? 36 degrees. Okay? If we know that angle, do you think we can find out this distance and this distance? Yes? Okay? Because we know that this is 20 miles, right? 20 knots. Okay, we know the distance here. We can find this distance, we'll call this distance y, and we'll call this distance x, by using sine or cosine and using trigonometry. Okay? So which one do you guys want to find first? Y? Okay, so y, am I using sine or am I using cosine? Okay, so what do I do?
20 over y.
Sine of 36 degrees equals y over 20. You're going to need a calculator for this, guys. So if you don't have a calculator, go ahead and grab one. All right. So you set it up correctly, but I need to solve for y. So I need to get y by itself. So how would I do that? You can do cross multiplication, right? So this will become y equals 20 times sine of 36 degrees. Right? Okay.
Oh, wait, you have to do that? I would've done the wrong way.
Okay. Listen up, okay? So you might want to write this. If you plug this in your calculator, because we are dealing with degrees, make sure that your mode is on degree. Okay? So if you're in radian, go to mode and change it to degree. Once you are in degree, then you can plug in 20 times sine of 36 degrees, close parentheses, and you're going to get that. Okay? Listen very carefully. We cannot round until the end. Okay? So here, at all, until the end. So pause. So what I'm going to do is, rather than taking this information, I am going to say that y equals to this, because that is an exact amount. Are you guys okay with that? Alright. Now we got to find x. So that would mean that cosine of 36 degree equals to x over 20, which means that x equals to 20 times cosine of 36 degrees. You guys agree with that? Okay? Alright. What we've done, if that just gives you an idea, is that this right here, this distance right here, is approximately, according to what we put here, 11.756 knots. Okay? Hold on. And we found out that the distance here is approximately, if we put this on the calculator, it'll be 20 times cosine of 36. It's approximately 16.180. Knots. Okay? Alright. Now let me ask you something. By finding that, how is that going to help us at all? If we add this plus that, then we have the entire distance from here to here, right? Yeah. And this forms a 90-degree angle. And if we know the distance from here to here, which we do, then we can use what theorem? Pythagorean theorem, okay? Alright, so here's what we're going to do. We are going to add these two numbers together, and we're going to square them. And then we're going to take this, square it, and then we'll take the square root of that, right? Okay? So here's what I want you to do. We're going to say 40 plus 20 cosine of 36 degrees squared plus 20 sine of distance right here, c squared. Cool? You guys follow me so far? Yeah. Alright. Plug it into your calculators. Try it. I want you to try it on your own to make sure that you can get the same thing. Make sure you're plugging it in the calculator correctly. Sorry. Okay? So try it. Okay. Alright, so here's how you do it. Parentheses. 40 plus 20 cosine of 36. Since you're opening up a parenthesis here, you got to close it. And since you had an opening parenthesis here, you got to close it again. And then it's squared. Plus, open parentheses, 20 sine of 36 degrees, close parentheses, and square. Okay? Once you do that, you hit enter, and you're going to get that c squared equals to all that. But we say that we don't want c squared, right? We want c. So in order to get c, I need to take the square root of this. So you're going to do second x squared to get the square root. And so you don't have to retype all this. If you hit second and the minus sign, that gives you the previous answer. Okay? And then you hit enter, and voila. 57.397 nautical miles or knots. Okay? So that answered part of the question, right? There is that. All right. You do know how to do the next part? All right. Go for it. No?
But you can make, okay, easy, you know how to do it. You can make a right triangle on the top, and take,
So like here?
right.
Okay. Let me see if I follow you. Then do what? No idea? Hold on. Brandon, you got something?
Yeah, you could either use cosine, sine, or tangent to find that one.
You can remember the inverse? Okay? If we're looking for this angle right here, okay? If we find this angle, then we can find the angle on the outside, which is the one that we need, right? But if the only way we're going to be able to find this angle out here is if we use this right triangle to find this angle right here. So let's call this angle theta. You guys okay with that? Yes. Which one? Right here? What is that called? Angle of what versus angle? So like you're saying, like if you know this angle right here, then you also know this angle right here?
The corner one, the one that was
Here? Okay. Yeah, we can do that. There's several ways to do this. Absolutely. Okay. So. Yeah. It is 90 degrees minus theta. but I mean, I want the exact angle. Okay? Alright, so I ran out of space. Let me get another sheet of paper. Alright, so tell me, what do you guys want to do? There's a couple ways to do this. Which way would you rather go?
Cosine of 40 over 40 over 57 or whatever.
Sorry. Here's the angle, okay? So if I'm trying to find the angle, look, if you want to use this triangle, do you guys agree that I could use tangent, the inverse tangent? Because I have the opposite side and you have the adjacent side, and I can do the inverse, and that will give me the angle here. And once I find that angle, then I can find this angle, right? Now, Kevin told me to do something else. Can you repeat it so that they know what another way to do this? You can come up and explain. Okay.
If you remember from geometry,
Guys, pay attention.
if you remember from geometry, the opposite or alternate interior angle theorem, these two are parallel. So therefore, this angle and this angle are congruent. So if you solve for this one, then you don't have to do the subtraction.
How do you remember
Okay. Very, very good. Okay. Guys, so let me elaborate a little bit. Remember that when you have, so I'm going to go off on this side. When you have a pair of parallel lines, and you cut them with a transversal, okay, then you know that this angle right here is congruent to that angle, right? And that means that it's also congruent to this angle, right? Because these are vertical angles, right? This and this, what?
equal
Alternate exterior angles are congruent. Very good. So if you remember geometry, you can do this. Okay? Because, guys, because we're doing trig, I'm going to do it the trig way. Go for it. I will not count it wrong. Okay? So because we're doing trig, I'm going to use tangent. Are you guys okay with that? Okay? All right.
No, I'm not okay with that. Let's do sine.
So according to this, we would have tangent of theta would equal to the opposite over the adjacent, right? So the opposite was 20 sine of 36 degrees, right? I will. Because we're using the calculator, I'll talk about it in just a second, okay? Alright, the adjacent happened to be 40 plus 20 cosine of 36 degrees.
Wait, are we not?
What's up?
I'm trying to think, can you not do like, do you have to do in tangent, or can you do cosine, sine as well?
You could, because you also have C, right?
Yeah.
I don't know. I don't know. It's up to you. It should get you the same answer. Okay? Honestly. There's not one exact way to do things, guys. As long as you can arrive to the answer, like I've always told you, and I can follow your work, I'm okay with it. If you want to use sine, then you will use the opposite over the hypotenuse, right? If you want to use cosine, then you will use the adjacent over the hypotenuse, which is what we found here. Remember? Okay? Alright. So from here, if you want to find an angle, you got to remember you got to do inverse, right? So this means that theta equals to inverse of tangent of this entire thing here. Okay? 20 sine of 36 degrees over 40 plus 20 cosine of 36 degrees. Okay? Do we need help plugging this in the calculator? No. Okay, try it. If you need help, just look up on the screen and I'll show you how to do it. Okay? So, we're doing inverse tangent, so I got to do second tangent. That gives me the inverse. I'm going to do alpha y equals to get a fraction template. On top, I have 20 sine of 36 degrees. And on bottom, I have 40 plus 20 cosine of 36 degrees. And make sure you close your parentheses. Alpha y equals. Okay. So, that means that theta is equal to 11.6 .819 degrees. Is that our answer? No. What do I need to do, Sam? So I need to do 90 minus theta, which in this case is 90 minus 11.819. Alright? So 90 minus 11.819 equals to 78.181. And that's your angle, right? But I need the bearing. So I need direction. Which direction did we go? So the answer is north 78.181 degrees west.
How long was that taking you right
And this was 57,397 knots. And that's the entire, okay? So that's like the unit of measurement that we use for this specific problem, okay? What's that? All right, guys, this was a lot for one problem. You guys realize that, right?
It's like a part
It is. It's a little tedious, but I want to make sure I didn't lose anybody. Okay? We're going to do a little recap, because this is the last problem I'm working with you, and then you're going to practice on your own.
Wait, this was the last one?
Yep.
That was the first one.
Exactly. Okay? All right. Let's do a recap of what happened. Okay? We had the ship leaving from here, going west at 40 knots. Once it got here, it went 54 degrees northwest. Okay? Remember, we start from the north, so that's 54 degrees. Forming the following triangle, because we want to know the distance from here to here, and we need to know the bearing, which the bearing that we're looking for in this case would be right here. That's what we need to know. Okay? Because we start from the north. We made this as a right triangle by adding this part to the triangle that we currently have, and we knew that this angle right here was 90 minus 54, which we got 36. Based on that, you were able to find both of these sides. Once you found this, that was the key to solving the entire problem. Okay? Alright. The only way you're going to get this is with practice. That's why we still have, 26 minutes left in class? I'm going to give you your homework. Okay? I want you to work on your homework. Like, you don't have an option today. You cannot play chess or whatever. I want to be able to help you. So, take out your textbooks or grab a textbook.